In the spring of 1943, the North Atlantic was a killing ground. Not a battlefield where armies clashed in open daylight, but a cold, invisible war fought beneath 60 feet of black seawater, measured in seconds and decided by sound. The Atlantic at that time was not just an ocean, it was a pipeline. Everything that Britain needed to survive and fight — food, steel, aviation fuel, rifles, vehicles, rubber, medical supplies — had to cross that water. There was no other way. The island was not self-sufficient. Without imports, the factories shut down. Without the factories, there were no weapons. Without weapons, there was no army. It was that simple, and it was that fragile. Germany had a weapon called the U-boat, a long steel cylinder packed with torpedoes and driven by men who believed they were invincible once they slipped beneath the surface. And for most of the war, they were right. From 1940 to 1943, German submarines sank over 3,000 Allied merchant ships. They were killing the British food supply. They were strangling the supply lines that kept armies fed, tanks fueled, and factories running. Winston Churchill later admitted that the only thing that truly frightened him during the entire war was the U-boat menace. Not the Blitz, not the fall of France, the submarines. Because if the submarines won, Britain starved. And if Britain starved, the war was over. The U-boat crews knew their importance. They were the elite of the Kriegsmarine, trained for months before deployment, taught to think three-dimensionally, in a world with no up or down, no horizon, no light. They hunted in Wolfpacks, coordinating attacks by radio, striking at night on the surface when radar was less effective, diving at dawn when aircraft patrols increased. Their commanders were celebrated in Germany as national heroes. Admiral Karl Donitz called them the Iron Men of the Deep. He meant it as a compliment, and the men who served under him earned the title in the most brutal way possible. Of all the German sailors who served in submarines during the war, over 70% did not survive it. They were the most effective and most expendable arm of the German military machine. The Allies were desperate. They tried depth charges, but they had to find the submarine first. They tried surface patrols, but the Atlantic is enormous. They tried radio intelligence, and it helped, but the submarines just kept coming. By March of 1943, more ships were being sunk than could be built to replace them. The math was brutal, and the math was winning. Merchant sailors knew the odds. Men who signed on to crew the cargo ships understood they were sailing through water where submarines hunted in organised groups. A convoy could leave Halifax, Nova Scotia with 40 ships. If a Wolfpack foundered in mid-Atlantic, it might arrive in Liverpool with 20. The survivors pulled from the water after a sinking had a matter of minutes before hypothermia became fatal. The North Atlantic in winter does not forgive hesitation. The water temperature in the worst months hovered just a few degrees above freezing. Sailors who went into the water rarely lasted more than 8 minutes. The merchant marine lost more men per capita during the war than any branch of any other service on any side. And then, somewhere in a classified laboratory, a small team of British and American engineers built something that changed the equation forever. They built a torpedo that could think. They called it the Mark 24. But inside the program, everyone knew it by a different name. They called it Fido. Now, to understand why Fido was so revolutionary, you need to understand how a submarine fight actually worked in 1943. When an aircraft spotted a U-boat on the surface, the submarine captain had one move. He ordered a crash dive. Every second mattered. The drill was rehearsed until it was automatic. Hatches slammed, ballast tanks flooded, diesel engines cut, electric motors took over. 35 seconds, that was the standard target. 35 seconds from the order to the moment the conning tower slipped below the surface. Once underwater, they were safe. Aircraft could drop the depth charges, but by the time a plane flew into position and lined up a run, the submarine had moved. It had gone deep. The charges exploded in empty water. The submarine slipped away. It was one of the most reliable escape routines in the war. It worked almost every single time. Almost. The idea behind Fido came from a deceptively simple observation. A diving submarine makes noise. A lot of noise. When a crew rushes a crash dive, the electric motors are screaming, the ballast tanks are rushing with water, the propeller shafts are churning. The faster the dive, the more noise, and noise travels through water with extraordinary clarity. It travels farther, faster, and more precisely than almost any other signal in nature. What if you could build a torpedo that listened? The engineers who worked on the Mark 24 were not household names. They worked in secrecy so tight that many of them did not know what the weapon would ultimately be used for. The project ran simultaneously in Britain and the United States, with teams sharing data across the Atlantic through classified channels. The core challenge was enormous. They needed to build a guidance system small enough to fit inside a torpedo casing, rugged enough to survive being dropped from an aircraft, and sensitive enough to detect the faint acoustic signature of a submarine propeller through hundreds of feet of open ocean. The solution they arrived at used 4 hydrophones, small underwater microphones, mounted at different positions around the nose of the torpedo. Each hydrophone listened to the water. When the sound of a propeller was louder on the left side than the right, the guidance system registered the difference. It sent a signal to the torpedo's control surfaces, and the torpedo turned left. When the sound balanced out, the torpedo was heading straight for the source. It was autonomous guidance. It was a weapon that hunted by ear. But the physics were brutal. Water carries many sounds. Fish, currents, the torpedo's own engine, bubbles from depth charges, the noise of the launching aircraft. The engineers had to tune the hydrophones to a very specific frequency range, the band where a submarine's propeller blades produced their loudest and most distinctive vibration. They called it the cavitation frequency, the sound of a propeller churning water into tiny bubbles that collapsed and snapped in a constant rushing roar. Early prototypes were erratic. The first tests in controlled conditions looked promising, but open ocean tests produced wildly inconsistent results. Sometimes the weapon worked perfectly, sometimes it circled back toward the launching aircraft. One test torpedo made 3 complete circles before running out of fuel. The engineers went back to their calculations. They adjusted the sensitivity thresholds. They changed the balance between the 4 hydrophones. They modified the tail fins to reduce overcorrection. It took months of painstaking refinement. The secrecy surrounding the project was almost suffocating. The weapon was so classified that the teams working on it were told it was an anti-submarine mine, not a torpedo. A mine. The designation was deliberate. If any Allied airman was captured and interrogated, and he mentioned that he had dropped a mine, the Germans would not be alarmed. Mines were passive, mines sat still, mines waited, but this weapon did not wait. This weapon hunted. The Germans could not be allowed to know that such a thing existed, because if they knew, they could adapt. They could change their dive procedure. They could muffle their propellers. They could design countermeasures. The entire advantage depended on surprise. So the weapon entered the war in disguise. Official paperwork described it as the Mark 24 mine. Aircrew briefings referred to it only as a special weapon. Even after its first successful kills, the Allied command refused to publicize the results. Pilots who used it were ordered to say nothing. If a U-boat was sunk by Fido, the kill was attributed in official records to conventional depth charges or patrol aircraft. The cover story had to hold or the weapon was useless. And the weapon was extraordinary. The operational concept was elegant in its simplicity. A patrol aircraft, usually a Liberator or a Sunderland, would spot a U-boat running on the surface. As the aircraft dove in, the submarine captain would do exactly what he was trained to do. He would order a crash dive. The plane would watch the conning tower disappear. Most pilots would have dropped conventional charges at that point and hoped for the best. But with Fido, the pilot waited. He let the submarine dive. He watched the swirl of disturbed water on the surface, that patch of white foam that lingered for 30 or 40 seconds after a submarine went under. Then, when the submarine was perhaps 50 to 80 feet below the surface, deep enough to be committed but shallow enough that it was still making maximum noise from the dive, the pilot released the weapon. Fido entered the water at a shallow angle. Its own engine ignited. The 4 hydrophones came alive, scanning the frequency signature they had been tuned to detect. And then, in the cold black Atlantic, it heard its prey. The faster the submarine dived, the louder it became. The more urgently the crew pumped water into the ballast tanks, the more noise the pumps made. The more the propeller churned, the stronger the acoustic signal. The submarine captain's instinct, the trained reflex that had saved dozens of crews in hundreds of previous attacks, was now working against him. Every correct decision was making him louder. Every correct action was making him easier to find. The first confirmed operational success came in May of 1943. A Liberator from a Royal Air Force patrol squadron caught a Type 7 U-boat running across the surface in the Bay of Biscay. The submarine dived on cue, the aircraft circled, the pilot released the weapon. Fido entered the water, acquired its target within seconds, and tracked it down through 200 feet of open ocean. The explosion was felt at the surface as a dull thump, followed by a spreading oil slick and debris. The submarine never surfaced again. News of the success was suppressed immediately. The pilot who dropped the weapon filed a mission report that described the kill as the result of a conventional depth charge attack. His squadron commander read the report, understood what had actually happened, and signed off on the cover story without changing a word. Somewhere up the chain of command, the kill was entered into a ledger that very few people were cleared to read. The crew celebrated quietly in their mess hall that evening, unable to explain to anyone outside their immediate circle exactly why they were so pleased with themselves. Within weeks, other crews began reporting the same pattern: a sighting, a dive, a drop, an oil slick. The mathematics of the campaign were changing, and the men doing the changing could not say why. Over the following months, the results accumulated. The crews could not talk about what they were doing, could not celebrate openly, could not even acknowledge the weapon's existence to colleagues outside their immediate unit. But the kill charts were telling a story that no one could ignore. Submarines that dived were dying. The escape routine that had protected U-boat crews for 3 years was suddenly, silently, catastrophically unreliable. The German submarine command noticed. They could see that some of their boats were being lost after diving, not before. They called it the Acoustic Torpedo threat and feared it deeply, even though they could not confirm its existence or understand exactly how it worked. Admiral Karl Donitz, who commanded the entire German submarine fleet, issued urgent orders. His crews were told to dive deeper, faster. They were told to zigzag during the dive to confuse any tracking system. They were told to increase speed during descent. Every one of those countermeasures made things worse. Deeper meant more time during the vulnerable transition phase. Faster meant more propeller noise. Zigzagging simply prolonged the descent. Donitz had ordered his men to do exactly what Fido needed them to do. The German response was, through no fault of their own understanding, the worst possible response. They had been handed a problem they could not see, and every solution they tried made the problem worse. The psychological pressure on U-boat crews was immense. Before Fido, a crash dive was a relief. It meant safety. It meant the aircraft above could no longer reach you. Sailors trained for it, rehearsed it, trusted it completely. After Fido entered the war, the dive became terrifying. The moment the hatch closed and the submarine went dark and the motors screamed and the hull groaned under the pressure, men started to wonder whether the thing in the water had found them yet, whether that engine sound they could hear was their own, or something else. Veterans who survived U-boat service in the second half of the war described a specific kind of dread that was unique to this period. It was not the fear of being bombed on the surface, which was predictable and visible. It was the fear of being beneath the surface and hearing a noise you could not identify getting louder. Closing, in the confined spaces of a submarine sense, travels through the steel hull like it travels through bone. You feel it before you hear it. And if you are one of the crew members who knew about the acoustic torpedo threat, the silence after a crash dive was no longer comforting. It was simply waiting. The British and American engineers had not just built a weapon, they had weaponized the dive itself. They had turned the most reliable protective instinct in the German submarine handbook into a liability. The faster you ran, the faster you died. By the end of 1943, the tide had turned decisively. May of that year became known in naval history as Black May for Germany, a month in which the Kriegsmarine lost 41 submarines, a loss rate so catastrophic that Donitz was forced to temporarily withdraw his boats from the North Atlantic entirely. Fido was not the only factor, but it was a central one. Aircraft that previously flew frustrating patrols over empty water were now converting sightings into kills with a consistency that had never been seen before. The lethality of air patrols doubled, then tripled. It is worth stepping back for a moment and considering what the engineers actually achieved. They built an autonomous homing system in 1943 with no computers, no transistors, no digital processing. The guidance system ran entirely on analog electrical circuits, carefully tuned hydrophones, and mechanical control linkages. Every component had to survive the shock of being dropped from altitude, the impact of water entry, and the violent vibration of its own engine running at full power. It had to operate in water temperatures that ranged from near freezing to temperate. It had to discriminate between the sound it was hunting and dozens of other sounds filling the ocean around it. The men and women who built it worked in conditions of total secrecy. They could not publish their results. They could not compare notes with colleagues outside the project. They could not even be entirely certain their weapon was performing as designed, because operational feedback had to travel through multiple layers of classification before reaching the engineers. They were working, largely blind, trusting their calculations, refining their prototypes, and hoping that what worked in a test tank off the coast of England would work in the middle of the Atlantic. It did. The number most often cited is 37 confirmed U-boat kills directly attributed to the Mark 24. Some historians argue the number is higher, perhaps as many as 46, when probable kills and shared credit for joint operations are included. Each one of those numbers represents a submarine crew of between 40 and 60 men. It represents a vessel that would never fire another torpedo, never interrupt another convoy, never sink another cargo ship carrying wheat or oil or ammunition. 37 submarines, at roughly 50 men each, nearly 2,000 sailors who had believed they were invincible once they went beneath the surface. Beyond the kills, the weapon transformed Allied strategy in a way that statistics alone cannot capture. Before Fido, a submarine that dived was essentially gone. Escorts and patrol aircraft marked the position and waited, but the submarine almost always escaped. After Fido, a submarine that dived was vulnerable for the entire descent. That changed the tactical calculus completely. Submarine captains who had previously dived immediately on spotting an aircraft now had to make a different calculation. Should they dive and risk Fido, or stay on the surface and fight it out with the aircraft guns? Neither option was attractive. Both options were dangerous. The submarine had lost its safe move. Strategically, the liberation of the North Atlantic supply lanes in 1943 was one of the decisive pivots of the war. Britain had been importing roughly 50 million tons of supplies per year before the war. By 1942, that figure had collapsed to under 30 million, and it was falling. Factories were rationing fuel, the bread ration was under pressure, military operations were being constrained by the shortage of imported raw materials. If the supply line had been cut completely, which German naval planners calculated was achievable by mid-1944, the Allied invasion of Europe would have been impossible. There would have been nothing to invade with. The reversal of that trajectory was not achieved by one weapon alone. It was achieved by a combination of code-breaking, convoy tactics, long-range aircraft, escort carriers, and new sensor technology. But within that combination, Fido played a decisive and largely unacknowledged role. It was the weapon that made the aircraft patrol lethal. Without it, air patrols were expensive deterrents. With it, they were killing machines. The secrecy held largely. The Germans suspected the acoustic torpedo existed but never fully confirmed the design. After the war, when German naval records were captured and analysed, it became clear that German submarine command had issued warnings about the possibility of acoustic homing weapons, but had never understood precisely how Fido worked. They had developed a towed noise device called Foxer, designed to emit loud sounds and draw acoustic torpedoes away from the submarine, but Foxer was designed around a different assumption about how the weapon operated. It was partially effective but never solved the fundamental problem, because the engineers who designed it were working from incomplete intelligence. Foxer was itself a problem for the submarines that used it. The device was towed behind the vessel on a long cable, generating constant mechanical noise. That noise masked the submarine's own ability to listen for threats. Submarine crews who deployed Foxer were essentially trading one vulnerability for another. They could not hear what was coming. The weapon designed to fool Fido often created new dangers of its own. It was the nature of the arms race that neither side could fully solve, because neither side had the complete picture. The weapon stayed secret, the cover held, and the submarines kept dying. There is a detail about the Mark 24 that tends to get overlooked in the broader history. The weapon was never intended to be perfect. It missed, it circled, it lost the signal in turbulent water. It sometimes tracked the noise of its own wake rather than the submarine. The engineers knew this. They never claimed 100% reliability, but they had designed something that worked often enough, reliably enough, and consistently enough that it changed the entire outcome of the campaign. In war, you do not need a perfect weapon. You need a weapon better than what the enemy can counter. And Germany had no counter. The Mark 24 remained classified until 1958. For 15 years after the war ended, the men who built it, the pilots who dropped it, the analysts who tracked its results could not say a word. The air crews who had turned the tide of the Battle of the Atlantic flew home to civilian life and could not tell. Their families what they had done. They could not explain why certain patrols had produced kills where others had failed. They carried the secret as a private weight. Some of those pilots went back to ordinary jobs. They drove delivery trucks, they taught school, they ran small shops. They sat at dinner tables and nodded when the conversation turned to the war, and then they said nothing specific. They had helped save a nation from starvation, and they could not speak of it for a decade and a half. That is a particular kind of sacrifice that history rarely records, because the men who made it could not record it themselves. When the classification was finally lifted, the engineering world took a belated look at what had been accomplished. What they found was remarkable not just for its effectiveness, but for its elegance. The designers had solved a tracking problem of enormous complexity using analog circuits, mechanical linkages, and a precise understanding of acoustic physics with none of the tools that modern engineers would consider basic. No microchips, no computing power, no software, just physics, precision machining, and a very clear understanding of what a cornered submarine sounds like. The Mark 24 was the first operational autonomous homing weapon in the history of warfare. It predated the age of guided missiles. It predated the transistor. It was built by engineers who had to solve problems with slide rules and test tanks, and it performed well enough to help change the outcome of a world war. The technology that Fido proved possible became the foundation for every guided weapon that followed. The acoustic homing principle it demonstrated is still used in modern torpedoes today. The basic logic, listen for the target, steer toward the sound, adjust continuously, is the same logic embedded in systems that are thousands of times more sophisticated. The engineers of 1943 did not just solve an immediate problem, they opened a door that weapons designers have been walking through ever since. The submarines that never surfaced after encountering it were hunting supply ships carrying grain to feed British families. The weapons they carried were aimed at the convoys that made the Allied invasion of Europe possible. Every cargo vessel Fido saved carried something that helped end the war faster. Food, fuel, vehicles, ammunition, soldiers. The U-boat captains who ordered crash dives in the North Atlantic in 1943 believed they were doing the right thing. They had been trained perfectly, their instincts were correct by every calculation they had ever been given. But somewhere above them, in the water and the darkness, a weapon they could not see was learning to hear them. The faster they ran, the louder they became. The more urgently they fled, the more precisely they were tracked. Donitz called his submarine crews the wolves of the sea. He believed they were hunters without equal, that the ocean itself was their weapon and their shield. For 2 years he was right, but the engineers who built Fido understood something that Donitz did not. Every hunter has a frequency, every predator has a sound, you just have to know what to listen for. Britain did not starve. The convoys got through. The armies that eventually crossed into Normandy were fed, fueled and fully armed because those hard-won North Atlantic supply lines held. And in a classified laboratory, in a report no one would read for 15 years, a small team of quiet engineers had already moved on to the next problem.